Okay, congratulations on surviving Module 1. Hopefully everybody's still got the same number of fingers and toes. We're going to move right on into Module 2 now. And we're going to begin with the notes on Chapter 7, which has to do with measurement. So when we're talking about measurement and assessment, we're squarely in the land of quantitative research. Qualitative researchers aren't really interested in these things because they don't help them answer qualitative research questions. However, measurement and assessment are vital to quantitative research. So do we really need to address the question of why we measure things? Well, probably not, but it's about accuracy and precision. Without measurement, our studies would lack rigor. With it, we ensure that we're comparing apples to apples in a standardized way that allows us to draw specific conclusions from accurate data. Now imagine if engineers were to build something as complex as a car engine by just eyeballing the components, trying to figure out how they all fit together. Obviously the thing would just blow apart the first second you turn it on, if you got to turn it on at all. Similarly, when we're looking at relationships between variables, our conclusions will just blow apart if we don't measure them accurately. So we're going to need to talk a little bit about different scales of measurement. Now there are 4 scales that are involved in quantitative measurements. These are the nominal, ordinal, interval, and ratio. One way to think about these scales is that each builds on the previous one. So if you look at nominal scale, that's the lowest level. It's determining categories that can't necessarily be ranked. So for example, gender is a nominal scale. You wouldn't claim that men are more than women or women are more than men. At least I wouldn't do that for fear of getting slapped. So I don't think you should either.
What?
Race is another nominal scale. Car color is a nominal scale. You know, these things where you can't necessarily position one as more or better or higher than any of the others. So with the ordinal scale, these are variables that can be ranked. Something like your year in high school. Freshman is less than junior, right? Or the Olympic medals, you know, gold is greater than silver is greater than bronze. There's not really a specific numeric value to these variables, but there is a way of sort of rank ordering them. If you were paying attention from the previous chapter, you'd probably notice that the nominal and the ordinal scales fall under categorical variables. The next 2 scales are continuous or quantitative variables, and the first is an interval scale. Interval scales use a specific numeric value with equal intervals between the different points. So the difference between 1 and 3 is going to be the same as the difference between 4 and 6, right? The main thing to remember with interval scales is that they don't possess what is called an absolute 0 point. So that means that either 0 doesn't exist on the scale, or it's a midway point and there are negative values associated with the scale. So something like the GRE scores, that's an example of an interval scale because they give you, I think, 260 points just for typing your name on the test. There's no 0 on the scale. It's not possible to get a 0 on the GRE, but your performance is measured in 1-point increments. So the ratio scale uses numeric values with equal intervals just like the interval scale, but it also includes an absolute 0 point. And this 0 point represents the total lack or absence of any value lower than 0. And that means that a ratio scale will not include negative numbers. Height and weight are measured on a ratio scale. You can't be negative 213 centimeters tall. That doesn't really make any sense, right? A lot of students get interval and ratio especially mixed up. I did, when I was learning this. So I'll give you another example before we move on. Let's talk about scales of temperature. We have Fahrenheit and Celsius, right? Both of those are interval scales. Why? Because you can have numbers that are less than 0, right? I'm more familiar with the Celsius because I'm Canadian and also because it just makes more sense. In Celsius, 0 is the point at which water freezes. I really don't know what 0 Fahrenheit means other than it's very cold. With 0 Celsius, you still have points beneath the 0 that you could possibly measure, like -1 and -12, right? On the other hand, there's the Kelvin scale. And the Kelvin scale is a ratio scale. Why? Because 0 Kelvin is the point at which all, atomic vibrations stop. 0 Kelvin is equal to -273 degrees Celsius, or -460 degrees Fahrenheit. So let's think about it, kind of mathematically a little bit. When we say 20 is twice as much as 10, right, on a ratio scale, what we're saying is that 20 is twice as far away from 0 as 10 is. It's relative to that 0 point. However, you can't say that 20 degrees Celsius is twice as warm as 10 degrees Celsius, because there's no absolute 0 point. In fact, if you were to graph those same temperatures on a Kelvin scale, they would be 283 and 293 degrees Kelvin, respectively. Obviously, there's not going to be that much difference between them. So when you're determining what kind of variable you're dealing with, you can ask yourself a series of questions. First, can I rank this data in a logical order? If not, you're dealing with a nominal variable. If you can, then you want to ask the next question. 2, is the variable represented in numbers with equal intervals? If it's not, then you've got an ordinal variable. If it is, then you ask yourself the next question. 3, does the variable use an absolute 0 point? If not, then you've got an interval variable. And if it does have an absolute 0 point, then you're using a ratio variable. It's kind of tricky to understand at first, so you might want to go back over this a couple of times, just make sure you're familiar with it. So that's the 4 different scales that we use in quantitative research. Next, I want to talk a little bit about error. And I've written here horseshoes, hand grenades, and research. So what's common between all of those? Being close counts. Now, error is treated sort of as a minor point in the textbook, but it's very, very important to quantitative research, so I don't want to just gloss over it. The first thing I want to say about error is that every quantitative study anywhere ever done contains some amount of error. And we're going to come back to this again when we look at sampling and the relationship between statistics and population parameters. But right now, let's talk about assessments. Let's say you're an economist, you're working for the government tracking trends in the gross domestic product, or GDP, over time. And you want to compare the rate of the GDP of the United States to some other country, let's say Japan. Okay, so the GDP is a what? Say it with me. A ratio scale. Good. So the gross domestic product, the GDP, is a measurement of every single person's productivity in financial terms within a single year. And we're talking about trillions of dollars in the US. It's actually 17.419 trillion to be exact. How possible do you think it would be for you to get an accurate report of the production of everyone, including all the people who don't actually report all of their productivity, or who lie, or who make mistakes, or simply don't care that much about the accuracy of your reporting as much as you do? I know it's frustrating, but it happens, Here's a better question. How much do you, as a researcher, care about differences of a fraction of a cent when you're comparing the GDP between the US and Japan? So what's the actual practical significance of the difference between $17,419 billion and $17,419 billion and 1 cent? Yeah, the word is negligible. It's as near to nothing as makes no difference. And even if we did care, to what degree do we actually care? How many digits beyond the decimal point do we need to get to before you're satisfied as an economist? Theoretically, we could just keep going infinitely to more and more precise figures. A tenth of a cent, a hundredth of a cent, a thousandth of a cent, and so on. Well, for the purposes of calculating a national GDP, the World Bank calculates in tens of thousands. That's their increment. Coming up with a more precise figure is not useful for them. It's too small. It doesn't make a difference. So a question for you to ask when you're doing your own research is, how close is close enough? How accurate do you need to be to create useful knowledge? Well, that depends a lot on what you're going to study and what you plan to do with the information. In general, we would say that more accuracy is better than less, but it does reach a certain threshold where you're putting in more work than you're going to get a return on accuracy. So that's one kind of error where the accuracy just doesn't reflect, the actual amount. There's some wiggle room that goes on there. We'll talk a little bit more about that later. Another thing to keep in mind is that assessments can produce false results. The reason for that is that people are weird and irregular. We're not all the same. Let's say I'm measuring height, That's pretty straightforward, right? I break out my ruler and I measure it in, centimeters. Just start measuring everybody, right? And I'm going to find out that the average height is about 179 centimeters. However, what we haven't taken into account is that some people may have better posture than others. They might stand up straighter than others. Some people may be wearing, thicker soled shoes or high heels, or maybe they have thicker socks on, They might have platform shoes and afros. So chances are, if I measured like 1,000 or 10,000 or however many people, some mistakes might be made. There might be some variation in the measurements. Now, something like this, the mistakes are probably going to be very minor, and they're not going to significantly distort the results. But they would be there, and undoubtedly they'd have some effect on the results. It might throw it off by maybe, a millimeter or a fraction of a millimeter or something. In other things, like if we're doing like a psychological assessment, our measurements are far less accurate and reliable than taking a ruler and measuring somebody. Therefore, there's this formula that you should keep in mind when you're reading any kind of results or doing your own research, and that is the truth, what actually is equal to the results that we find, plus or minus some degree of error. Now, the job of the researcher is to make the error as small and tiny as possible, just a little tiny error, so that the difference between the results and the truth is what we would call negligible. So, let's talk a little bit about reliability and validity. These are very, very important concepts in quantitative research. It's another pair of concepts that's very easy to get confused, and I got confused quite a bit when I was learning this initially. You can think of reliability as the consistency of the results, while validity refers to their accuracy. So back when I was taking this course, here's how it was explained to me. Imagine that you're at the firing range, and you're testing out a new rifle. If the rifle is reliable, you're going to have a tight, consistent grouping of shots, right? If the rifle is not reliable, the shots will be spread out. They'll be kind of all over the place. If the rifle is valid, then you'll hit what you're aiming for, which is obviously the center of the target. If it's invalid, then you're going to miss consistently. Now, it's possible to have a consistent grouping of shots that's nowhere near the bullseye. Say if your gun consistently pulls, to the left. However, if your shots are just all over the target, and some of them miss the target, and go into the walls and things, then can you actually say that you're accurately aiming at anything? Therefore, it's possible to have reliability without validity, but not validity without reliability. Let's use the Beck Depression Inventory as an example of an assessment. This is a real thing. Beck Depression Inventory has been around for forever. It's been well tested. And it's widely used by clinicians to assess the client's level of depression. It consists of 21 multiple choice questions, and then it produces a total score that ranges from 0 to 63. And the higher the score, the more depressed the person is. And the Beck Depression Inventory is regularly abbreviated BDI, which is not Liam Gallagher's new band. Make the thunder and lightning sing in the eye of a storm. So in relation to reliability, there are a few different ways that we can test the reliability of the BDI. The first, and probably one of the most common, is the test-retest reliability. As we noted earlier, reliability means that we're going to produce consistent results. So if I give you the BDI once and then I give it to you again, I should see fairly similar results, assuming, nothing else has changed. However, if I give you the BDI once and I find out, you're severely depressed, and then I give it to you again maybe a couple hours later, and it shows that you're only mildly depressed, I'm going to start wondering what's going on. It's not necessarily results that I want to trust. So reliability is calculated as a correlation, a relationship between variables, in this case between test 1 and test 2. And the scores are going to range from 0 to 1. Now in reliability there's no negative scores, right? So it's all positive. So the BDI has a retest reliability score of 0.93, and that's hugely high. You can look that up in the Mental Measurements Yearbook. That's a good resource to remember. People who are depressed tend to stay depressed. Now, something to keep in mind is that you want to reduce the time between testing as much as possible. The more time that you have between, your first and second test, the more chance there is for all sorts of other stuff to come in and affect the results of the second test, And so you want to kind of rule that out by having the tests as close in time as possible. Another kind of reliability that we might be interested in is called the equivalent forms reliability. So let's take a trip to Montreal in our imagination.
Speeding through the universe, thinking is the best way to travel.
Canada is a bilingual country with both French and English as the official languages. Therefore, we're going to want both French and English versions of the BDI if we're going to use it in Quebec. But how would we know if the translator did a good job in translating the assessment? What if there were some slight changes in the language that actually produced different results? That would be a problem, wouldn't it? Therefore, we'd want to gather up a bunch of bilingual Canadians and test the French version and the English version with them and make sure that the results of the two versions are fairly similar. Otherwise, we're going to have to revise our translation. So another type of reliability has to do with internal consistency. As I mentioned earlier, there's 21 items on the BDI. When we're looking at internal consistency, we want to know that all 21 items are measuring the same thing. If your assessment is measuring a whole bunch of different stuff, then you're going to have pretty low reliability. You don't really know what the results mean. The main way to measure internal consistency is what is called Cronbachs Alpha, which is a big statistical test. Basically, the alpha coefficient is the average correlation of every item with every other item in the assessment. So you want to find out how results from item 1 correlate with results from item 2, and how 1 correlates to 3, and 2 to 3, and so on and so forth. And generally what you want to see is that there's a high level of consistency between the items. So if item 1 shows that they're severely depressed, item 2 shouldn't show that they're just only mildly depressed. So when we get a consistency between all of these items, then we get an unambiguous result that we can actually use. So in the old days, calculating Cronbachs Alpha was super tedious. I mean, think about it. You have to do correlations for every single item with every other item. It's a lot to do. For the BDI, there are 21 items. I'm not sure really what that calculates to. The book says there's 190 correlations for 20 item tests, so a little bit more than that. So what researchers would do if they wanted to do kind of a quick cheat was to do sort of a split half comparison. So they would split the test into two sections. They might do like even and odd numbers, or the first 10 and the last 10 or something like that. And in this way they could kind of arrive at sort of a fair approximation of what Cronbachs Alpha would have been. Nowadays we have computers to help us do these kinds of calculations, so we really don't need to be intimidated by the number of correlations or anything. It's actually not too bad.
I'm the operator with my pocket calculator.
And then we've got inter-rater reliability, which is a little bit different than some of the others because it involves sort of a subjective assessment as opposed to sort of an instrument. The most obvious example I can think of right now off the top of my head is figure skating, where you have a panel of 9 judges who watch a figure skater's routine. Then they score them on a scale of 0 to 6. So, if you just had like a single judge sitting there, doing the scoring, then it would be kind of like this.
Yeah, well, that's just like your opinion, man.
But if you can get agreement between the 9 different judges, or let's say 3 in a peer review, then you have a stronger basis for making conclusions. It's not just one person's opinion. And that reduces bias. So inter-rater reliability is a way that we can measure how much agreement there is between different raters or judges. So we talked about reliability. Now we're going to switch to validity, particularly as it applies to quantitative assessments. You'll remember earlier that validity is the way that we describe the accuracy of an assessment. Are you measuring what you claim to be measuring? Now there's a few ways to demonstrate that your assessment is valid. One is content, two is the internal structure, and three is a relationship to other variables or other established assessments. So generally, when you're developing an assessment, you want to go out and, like in research, you want to study the existing literature that's out there. Usually a well-developed assessment is going to include a literature review to indicate, a basis in theory and other empirical research out there that supports the validity, so it's not just sort of something that the test developer just made up out of thin air. But as you're reviewing it, maybe you don't have access to that literature review. Sometimes it's just a matter of common sense. Do these items actually make sense? Do the items that are included in the BDI make sense given what we know about depression? I would say they do. And when you take all 21 items together, they give you a pretty good picture of whether somebody's depressed or not. And they cover different aspects of depression, like mood or sleeping habits or, appetite increases or decreases. Those are all common symptoms, and I could look them up in the DSM to see. You can also assess the validity of the internal structure of an assessment. And that's kind of similar to what we were talking about with Cronbachs Alpha. You want to see a high internal consistency between the items. So the BDI measures depression. That's it. That's all it does. However, some constructs are not as easy to assess. For instance, personality. It's very difficult. One popular assessment for personality is the Myers-Briggs Type Indicator, MBTI. According to this assessment, personality actually consists of 4 subdomains that are interrelated. These are introversion and extroversion, sensing and intuition, thinking and feeling, and then judging and perceiving. Each of these subdomains is assessed on a continuum. So, for example, I'm an INTP. I'm really extreme on the introversion, but I'm pretty much borderline between judging and perceiving. So the different combinations create 16 personality types, and then there's variance within the personality type too. So somebody may be strong on sensing versus somebody who is sort of moderate on sensing. The thing is, you can't predict whether somebody's going to be sensing as opposed to intuitive, based on whether they are introverted or extroverted. One doesn't depend on the other. They're somewhat independent. So something you want to take away from this is to consider when you come across the assessment, have the people who developed it actually considered all the different aspects of what it is they're trying to assess? Or have they only measured some part of it and left some part out? A good assessment should be specific as possible, but also as comprehensive as possible. And in some cases, one assessment is not enough. Several different assessments are required. For example, the Armed Services Vocational Aptitude Battery, or ASVAB, which is supposed to help the military figure out, what you should do or where your talent fits best in the services. And then we have validity in relation to other variables or established assessment. We can divide assessments into 2 groups. They're norm-referenced or criterion referenced. A criterion reference sets a certain point or criteria for determining a result. BDI is criterion referenced. There are thresholds for determining various levels of depression using the BDI. So for example, 0 to 13 indicates minimal depression, while 29 to 63 indicates severe depression, like you need to be hospitalized. On the other hand, something like an IQ test is norm referenced. Now keep in mind, the IQ scale is an interval scale. There's no 0 point. Instead, IQ is referenced by a central 100, and 100 represents the average intelligence of the entire population, which means that 50% are going to be below 100 and 50% are going to be above 100. Of course, 85% of people think they're above average.
I'm a college man. I won't need my high school diploma anymore. I am too smart. I am too smart. I am too smart. I am too smart. S-M-R-T. I mean S-M-A-R-T.
The thing with me is that I am smart, and I'm self-smarted, basically, by myself. Basically from nature and smoke and drugs and doing different things, I've self-learned myself.
Furthermore, because of statistics that we're not going to get really too much in depth with here, we know that 68% of the population falls between 85 and 115 on the IQ scale, and that 95% of the population falls between 70 and 130, and there is 99.75% between 55 and 145. Meaning there's only 0.25% that are beyond those kind of extreme scores. So when somebody takes an IQ test, they're not meeting a criteria that says, you are smart, or you are gifted, or you are stupid, or anything like that. They're being compared to everybody else who has taken the IQ test. In addition to referencing norms or criteria to judge how a person has done on the assessment, assessment developers can also reference outcome variables to determine the validity of their assessment. We talked about the GRE a little bit earlier. GRE is useful because it's actually correlated to success in grad school. If it wasn't, well correlated, then there would be no point in taking it. However, the developers of the GRE have been able to give somebody this assessment and then see how well they do and see how that's correlated. So the GRE is an example of a predictive assessment. It predicts what's going to happen in the future. It wouldn't make much sense to have somebody graduate and then take the GRE.
Don't smoke. I'd like to say thank you on behalf of the group and ourselves. I hope we pass the auditioning.
On the other hand, the Beck Depression Inventory, or BDI, has concurrent evidence for its validity. The people who are being assessed by the BDI are depressed now, not sometime in the future. But with both cases, what we're looking for is that there's an agreement with the results. So the BDI, we want to see that their score correlates with them actually being depressed. And in that way, we would determine that the assessment is valid. And then the final ways to demonstrate the validity of an assessment are called convergent and divergent evidence. Let's say that I'm an assessment developer and I have developed an assessment for depression called Maxfield Assessment of Depression, MAD. So let's say the MAD is 2 questions shorter than the Beck Depression Inventory and costs $15 less, so there's a benefit to it. The question we want to ask, though, is it any good? Is it actually going to work? Does it do the same thing as the Beck Depression Inventory? So what I would want to do then is get a whole bunch of people together, and test them with the MAD and the Beck Depression Inventory so that I can compare the results between the two. To the extent that the MAD indicates an agreement with the already well-established Beck Depression Inventory, I would have established convergent validity. My assessment is valid because it does the same thing and shows the same results as this already proven assessment. Of course, haters are going to hate. And so some critic might come up and say, well, your test doesn't actually measure depression, it measures anxiety. So in order for me to demonstrate that my test is valid, now I need to show that it does not measure anxiety. I want to show that the results are divergent, meaning they're not the same, from an established assessment that already measures anxiety, such as the Beck Anxiety Inventory. Beck was a pretty busy guy. If there are low correlation between the results of the MAD and the BAI, then I can actually claim that my test is valid because it has little agreement with something that measures anxiety. It's not measuring anxiety, it's measuring depression.
Shut up!
So before we conclude, let's come back to ethics and the ethics of doing assessments. You might have an assessment that's valid and reliable. It could be this amazing creation that can provide valuable insights, but you have to keep in mind the assessment is not God, and it's not any substitute for common sense. All an assessment does is convert input into output. Beyond that, it relies on human interpretation.
Whoop-de-doo! What does it all mean, Basil?
So we need to be careful about how we make sense of the results and how we present them to the people that we're assessing. Furthermore, we should never impose the results of an assessment over, the will or lived experience of our, test takers. Let me give you an example. In my master's, which was like a long, long time ago in a galaxy far, far away, I took a career counseling course. And as part of the course, we had to take a lot of vocational assessments and then consult with a career counselor and present our results to the class. So one of the assessments that I took came up with the following recommendations. 1, I could be a machine operator. 2, I could be a circus performer. Or 3, I could be a gynecologist. I have no idea what the common connection is between those 3 careers, or what answers I gave that prompted that kind of response. I'm open to any ideas if you have any. But in any case, I was able to sit down with the career counselor afterwards, and we got to sort of have a laugh about it. I was already pretty set on a career path, being that I was in a master's in counseling program. And the counselor said, okay, we'll just keep doing what you're doing then. Now, if it was a less ethical counselor, they might have insisted that no, my options were limited only to, those 3 things that had come out of their assessment. All I could ever be is a machine operator or a circus performer or a gynecologist. There was no other option for me. And maybe if I was less confident in my career path and I was kind of searching around for an idea, I might have actually been defined by those results. I might have said, okay, that's all there is for me then. So we do need to be careful about how we present our results to people who have taken our assessment. We also need to consider that assessments may be biased, and we're going to talk a little bit more about that in, I think, the next video. But they may produce results that are systematically discriminatory towards certain groups of people or privilege others, particularly when we attach high stakes to them. So we need to be sensitive not only to the results of the assessments, but also to the ways that assessments operate to produce those results and how they function within our society. There's an old Zen proverb about a finger pointing at the moon, which is that only a fool would mistake the finger for the moon. Similarly, an assessment is nothing but a finger pointing us in the direction of what it is that we're measuring. It's not the thing in itself. And this is particularly true for intangible psychological constructs like aptitude or depression or intelligence. However, for better or worse, we're living in an era of accountability where we have assessments and measurements for pretty much everything. Now, that's not to say we should dismiss assessments entirely. I think they can be quite valuable. But we need to exercise caution when we perform and interpret our assessments.